Okay, let's look at some other types of problems we'll see for this. Okay, what is the vertical cross section going through the center of the figure shown? So vertical means like we're cutting vertically right here. So it's going through the center. So it would be like cutting it in half right here. All right, what would we get? It's going to be a triangle. Okay? Now, as far as me showing you, like it's going to look kind of like that. It'll be a triangle. Cut it in half. Question for you on that one. What if they had asked you to cut it horizontally? I believe that this is a square, like a rectangular pyramid. So if you cut parallel to the base, I think this is always true. If you cut parallel to the base, it's always the same shape as the base, right? So if we were to cut this horizontally, it would be the same shape as the base. I think that's meant to be a rectangle there, although maybe trapezoid, but I think it's meant to be a rectangle there. It could possibly be a square in that case. But the question as it's written is asking for vertical, which would be a triangle. Okay? All right. Example 2. Daniel cut the corner off of a cube. As shown in the diagram below, points A, B, and C are the midpoints of the edges of the cube. What type of three-dimensional figure has been cut off? Oh, I think we're narrowing it down to C or D. Would it be a prism or a pyramid? It's going to be a pyramid because it would have been pointy on the end, right? So this would be like the base right here. And then there would have been like a corner over here, and so it would be pointy. There would be no rectangles. The sides would be triangles for that. Okay, I think 3 is an interesting question. In fact, that cone that Kaylee has back there could help us answer. A right circular cone is represented by the drawing below. Which figure could not be a cross section? Which one? D. It's going to be D. Okay, how would we get the circle? We'd like karate chop it this way, right? How would you get the B? How would you get B? It'd be cross karate chop there. How would you get C? This way, right? But you would never get a rectangle out of it. There's no way to get a rectangle. Not with just the one cut. Not with just one cut. You can set it right there on that table for me. Thank you, Kaylee. Okay? All right. Let's look at this. Okay. Now, this next part that we're going to talk about is rotating a figure. And this is actually something we do a lot in calculus, because in calculus we actually find the volume of it, and it's like some complicated integral stuff. We don't have to do that at all. All we're thinking about right now is just like picturing what would happen. So I've got a few things that I use for calculus. lost my decorations that I usually use for this. The more that you like see, the more you can know about it. I know but that would be a cylinder. Okay? All right. So, Kathleen rotated an isosceles trapezoid 360 degrees around its longest base. Which choice could be the resulting solid? So, first of all, let's talk about what an isosceles trapezoid is. Trapezoid with the two legs are the same size. So, it would look like this. Oh, pretend that's even right there. And then you're rotating it around that longest base. It's going to be C. So, like, this middle part's like a rectangle, so that's going to give you a cylinder in the middle. And then the two side parts, those triangles, are going to be like cones. Okay? Questions on that? Good, because I don't know if I could explain it any better if you tried. Okay? All right, then the last part of this that we have to think about is a net. So a net is a pattern that you can cut and fold to make a three-dimensional geometric shape. So for a net, for example, this would be the net of a cube, right? Or a net. There's some other ways that you could do it. But we could take this, we could fold those two sides up, fold this side up, and over. One thing I can think of, this makes me think of, when I make cakes, sometimes I buy like cake boxes to put them in, and they come as just like a flat sheet of cardboard, right? Because it's hard to ship an actual box folded up, and it would cost a lot of money just to ship them all folded up, right? So they come as just a flat sheet of cardboard, and you got to fold all the edges up and get it to fold up. Match each net to its solid. So number one, what would that be if we folded it up? It is a cylinder. You'd fold the ends over and like wrap that rectangle around. That would be a cylinder. So this one would be A. What would this one make? A square pyramid, because the base is a square. And you got all those triangles that would fold in to touch in the middle. That would be C right there. What about, obviously, through the process of elimination, this one has got to be B. But that one's going to be a triangular prism. You fold the ends up, and you got all those rectangles on the side. Remember, on a pyramid, all of your lateral sides are triangles. So if it's a pyramid, there should be a bunch of triangles in it, right? If it's a prism, what are all your lateral sides? Rectangles. So it should have a lot of rectangles in it. Maybe squares instead of rectangles, but it should have a lot of rectangles there for those. So, this is about all I can really do to like teach you this, right? Just kind of go through a few examples. So, what I've got for us for the rest of class, and we'll probably go over it before we go, because this is not something that like takes a long time to do. You just kind of have to like look at it and see if you see it. So we'll probably go over this before we go. Is I just have a pretty long worksheet because it's got a lot of examples, and you guys are going to work on answering these questions.